Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 10, part B of the May-June 2023 Pure Mathematics P1 Cambridge 9709 syllabus. This is paper 1, variant 1, paper 1-1. And this question is involving differentiation, equations of tangents and normals, and so on. So I've put it in a separate page to the, or separate video, sorry, to the part A, which is dealing with integration, more to do with integration. So now it says here, a triangle is formed from the tangent to the curve at B and the normal to the curve at B and the x-axis. Find the area of this triangle. So we have to have, just make it bigger actually to make it clearer for us. Okay, so we have to have, I'm going to draw the tangent to the curve at B. Now the tangent to the curve at B is just a line which is going to be a straight line which shares the same gradient of this curve at the point B. It can be something like this. Something like that. Okay, and that's the equation of the tangent to the curve at B. Now, there's also the normal to the curve at B, which basically goes through B as well, but it has a gradient which is perpendicular to B's gradient. So it's going to go something like this. So it's going to be perpendicular to B, passing through, perpendicular to the tangent at B, passing through B as well. Okay, and we got to find where these meet the x-axis. Let me make this a bit thicker here so we can see it. So we got to find the area that's enclosed between these points. Okay, the area of this triangle. Okay, between the tangent and the normal and the x-axis. That's what we have to find, this area over here. So to find the area, we need to know what these 2 points are. To find what those 2 points are, we need to know the equation of the tangent and the equation of the normal to the curve at B. So to find the equation of a straight line, which they both are, you need 2 things. You need to know the gradient of the line. So we need to know the gradient of the tangent and the gradient of the normal. And the second thing we need to know is a point that the line passes through. For both of them, B is a point that we know they pass through. Okay, so using this information, we can now find the equation of the tangent and the normal to the curve. Okay, so now in order to do that for the tangent, I need to know the gradient. And the gradient is found by using the gradient function, which is dy dx. Okay, so we have our function. We got to find what dy dx is. So we have 4 equals, y equals 4 times 2x minus 1 to the power of negative 2. Get it ready for differentiation. Now, when we differentiate this, we have to use a chain rule. Okay, so I'm going to just use a chain rule here. So I'll say dy dx equals, now be careful when you use the chain rule. Many people forget things. First of all, we multiply by the power. So minus 2 times 4 is negative 8. We leave the bracket exactly as it is, but we take 1 from the power, so this becomes negative 3. A lot of people make the mistake, put negative 1. You take 1 away from the power, so minus 2 minus 1 is negative 3. And don't forget then, you multiply by the differential of what's inside the function. That's the most common thing for people to forget. This is going to be using the chain rule. So you always, after you differentiate the main thing, you multiply by the differential of what's inside the function. So this gives us an expression. We can say dy dx is going to be, you can say negative 16 over 2x minus 1 to the power of 3. That's the gradient function. So we can say that the gradient of the tangent is going to be when x equals 3 over 2. We're going to find the gradient of the tangent at B. So we're going to replace the x with 3 over 2. So 2 times 3 over 2 is going to give us 3. 2 times 3 over 2. Sorry, 2 times 3 over 2 gives you 3. 3 minus 1 is 2. 2 cubed is 8. That gives you 8. So that gives us negative 2. So the gradient of the tangent is -2. So the gradient of the normal is going to be the negative reciprocal of -2, which is +1/2. So this has a gradient of -1/2. Sorry, this has a gradient of, the tangent has a gradient of -2, and the normal has a gradient of +1/2. So -2 and +1/2. That looks kind of sensible here. So now we can find where the lines cross the x-axis. So I'm going to begin finding the equation of the tangent. So if I start finding the equation of the tangent, okay, I know it passes through the point B, which is 3/2, 1. So when x equals, so basically we have y minus y1 equals m times x minus x1. Okay, so the equation of the tangent will be y minus y1, which is 1, equals m. The gradient of the tangent was -2 times x minus 3/2. Okay, so now what I can do here, because I don't really have to find the equation of the tangent and the normal, I just need to know where it crosses the x-axis. So it crosses the x-axis, we know when y equals 0. So I can just replace the y with 0 here. So if I replace the y with 0, I'm left with -1 equals -2x plus 3. Okay, so I can find the x coordinate. I'll have 2x equals 3 plus 1, which is 4. Therefore, x equals 2. Okay, so we have found the x coordinate of this point here. So this is going to be where x equals 2. All right, and then we're going to have the equation of the normal. So we can find where the normal hits the x-axis as well. So we're going to have here y minus y1 equals m times x minus x1. In this case, the gradient of the normal is going to be a half, +1/2. So we can use the same point because they both pass through the same point. So y minus 1 equals the gradient, which is going to be +1/2 times x minus 3/2. Okay, and we can again put y as 0. So we're left with -1 equals, you can say, let's multiply by 2 as well. So -2, just multiply both sides by 2, equals, and you're going to have x minus 3/2. So therefore, x is equal to -2 plus 3/2, which is going to be -4/2 plus 3/2. That's going to be -4/2 plus 3/2 is -1/2. Okay, so I know that this coordinate here is -1/2. So I can find the equation of this, or the area of this triangle. I have basically, if you think about it here, what we have is a vertical height. This is the vertical height, which is 1 unit, because that's the y coordinate at that point. And you've got the base distance, which is the difference between 2 and -1/2, which is 2.5, you could say. So the area is a half times base times height. So the area is a half times 2.5 times the height, which is going to be 2.5/2. Okay, which is going to be what? That's 1.25 square units. You can say 5/4 square units. And there's the answer to part B of this question, okay, which was dealing with differentiation, equations of tangents, equations of normals. Okay, so the reason why I didn't go on to find the actual equation of the line, because we don't need it. We just need to find where it crosses the x-axis. So that's why I just replaced y equals 0, so that we can find where they cross the y-axis, and therefore we can find the area of the triangle formed between the tangent and the normal at B with the x-axis. Okay, so there's the answer to question number 10, part B. I hope that was clear. Other questions from this paper, including 10, part A, can be found in the playlist that will be linked in this area at the end of the video. Other questions from the topic of differentiation from from P1 can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch a video here which tells you how to use my channel to find things that you might need. Thank you for watching, and see you soon.